This video is about luminosity and apparent brightness. Earlier we learned about luminosity, which we can define as the total power radiated by an object. We also introduced the following luminosity formula. Luminosity is most often used in the context of stars that, as we also mentioned, are almost perfect blackbody radiators. Another key term that is often used in astronomy is apparent brightness. So let's move on to learn what we mean by apparent brightness and how it's related to luminosity through a formula. We'll begin by picturing a star, so for example our Sun. If we are far enough from the Sun, so for example on Earth, we can treat the Sun as a point source that radiates power in all directions. The total power radiated by the Sun is evenly distributed over a spherical surface area. Of course, our drawing here is simplified from 3 dimensions to 2 dimensions. Now imagine that our beautiful planet, the Earth, is located here at a distance d from the Sun. Recall from earlier that in this context I, so intensity, can be defined as power radiated or received per unit area. Thinking a bit further, we can express the intensity of solar radiation at the position of the Earth. The total power radiated by the Sun is its luminosity, so L. The key here is to understand that this total power is distributed over the entire surface area of a sphere that has a radius of the Sun-Earth distance that in our drawing above we denoted using the letter d. This surface area of a sphere is 4 pi times the radius squared, so to get the intensity of solar radiation at the position of Earth, we'll divide the total power radiated by the Sun, so its luminosity, by the surface area of this sphere, so by 4 pi d squared. In astronomy, instead of calling this value the intensity of a star, we call it the apparent brightness of a star. Here is the formula that you find in your data booklet for apparent brightness, and this is how the variables in this formula are defined. Another way to think about the apparent brightness of the Sun is that it is the power received by, for example, a telescope at the surface of the Earth. Both luminosity and apparent brightness have important applications in astronomy, and we'll learn a bit more about some of these applications in subtopic E.5. Let's see a final point about luminosity before we wrap up. Luminosity is a power value, so it is measured in watts. When we want to express the luminosity of a star, we can do it in watts, or, as it is often the practice in astrophysics, in terms of the Sun's luminosity. The symbol that we use for the Sun's luminosity in the IB Physics course looks like this. So we have now completed our learning about luminosity and apparent brightness.